In the last video we found that the sine of x can be written in terms of tan of x as tan x divided by the square root of 1 plus the tan squared of x. So it follows then that the sine of a half of x, or x on 2, is equal to the tan of x on 2 divided by the square root of 1 plus the tan squared of x on 2. We also found that the cosine of x can be written as 1 divided by the square root of 1 plus tan squared of x. And of course it follows that the cos of x on 2 would be equal to 1 over the square root of 1 plus tan squared of x on 2. So pretty straightforward. But recall from the sum difference formulas for sine and cosine that the sine of 2 alpha is equal to 2 times the sine of alpha by the cos of alpha, and the cos of 2 alpha is equal to cos squared alpha minus sine squared alpha. So these are called the double angle formulas, where the angle here must be twice that of the angle in here. And again, the angle on the left hand side must be twice that of the angles on the right hand side. So it follows then that the sine of x is equal to 2 times the sine of x on 2 by the cosine of x on 2. And before I make these substitutions, let me write this as t divided by the square root of 1 plus t squared. So where t is equal to tan of x on 2, just to make the notation a bit simpler. So we have here as well 1 divided by 1 plus t squared. So if I make this substitution, I get 2 times t divided by 1 plus t squared times 1 over the square root of 1 plus t squared, and this equals 2t divided by 1 plus t squared. Similarly, for the cosine of x, we can write this as the cosine squared of x on 2 minus the sine squared of x on 2. So here we have 1 on the square root of 1 plus t squared all squared minus t divided by the square root of 1 plus t squared all squared, and this equals 1 on 1 plus t squared minus t squared on 1 plus t squared, which simplifies to 1 minus t squared divided by 1 plus t squared. So once again, sine x is equal to 2t on 1 plus t squared, and cos x is equal to 1 minus t squared on 1 plus t squared, where t is equal to the tan of x on 2. And you may be wondering, why would you bother writing sine of x in these terms? Well, this will become clear when we start performing integrals of fractions involving trigonometric functions, or in other words, sine, cos and tan. And these expressions will help us simplify the integrals to an expression that we can integrate. So that's it for this video. Please give me a like if you have found this to be useful, and please share. And please feel free to subscribe to my channel for future videos that may help you with your math studies. And by all means, if you have any questions, please ask by using the comments below.